All right, so your homework last night was to write the orbital notation for oxygen, write the electron configuration for the oxygen atom, then write the orbital notation for the most likely ion of oxygen, write the name and just the symbol for the ion of oxygen, the most likely ion for oxygen. And then I think in the first period I asked for also you to write the electron configuration for the oxide ion. So we're going to start with the oxygen atom. And the orbital notation you start with the symbol for oxygen, must be there, a colon must be there, and then we're going to write out all the boxes that represent orbitals, the sublevels underneath that, labeling sublevels and primary energy levels for all those electrons, and then we're going to put the electrons as arrows inside the boxes that represent our orbitals. And the arrows have to have an upspin first and a downspin second. So based on the placement of oxygen right here, we know that we're going to fill up the first primary energy level. Okay, the placement of atoms on the periodic table represents, one of the things it represents is filling up electrons in orbitals. That's why they work out that way. So we're going to fill up the first primary level, which only has a S sublevel. Helium actually belongs here when we talk about sublevels. And so these first two columns then with helium at the top of this one is the S sublevel region. So the first thing we're going to fill up is one S and there's two electrons. And then we're going to fill up two for the second row on the periodic table called a period. And the placement of lithium and beryllium on this second row means they're showing where we're adding electrons to a primary energy level and to a sublevel. So it's 2, and these first two columns is S, 2S. When we get over here, we're in the second row, so it's still primary energy level 2, but we're in the P sublevel region, and we have 1, 2, 3, 4 electrons we need in the P sublevel region. So here's our 1s orbital. So it's first row representing the first primary energy level. We're filling up electrons in the first row. Hydrogen and helium are in S, the S sublevel region, the first two columns. And there are two electrons, one for hydrogen and one for helium. And then we're going to go to 2s. Whoops, I'm sorry, 2s is up here. So this is 2s. Take where I started to write the box in the wrong place out of there. So this is lithium and beryllium's electrons. And then we get over here where oxygen is in 2p. And P sublevels always have 3 orbitals every time. Even though there's no electrons in there, you still have to write down the orbitals. They exist even if they're empty once you get to the P sublevel region. And so oxygen needs 4 more electrons, and the way you fill them up, 1 electron in each box, and then you can go back and pair them up. Okay? And so that's the orbital notation for the oxygen atom. Okay? The electron configuration is kind of a condensed version of this, so we just write the symbol for oxygen, just like we did here. Must be there. You can't just write the electron configuration without the symbol. The colon there separates the symbol from the actual electron configuration. We have 1s just like we have in orbital notation, but we simply count the electrons in this sublevel. And there are 2 electrons in this sublevel. And that becomes a superscript. And then we have 2s. We count the electrons in that orbital. And that's a superscript 2. And in 2p, we have 1, 2, 3, 4 electrons. So we count those and we put them as a superscript. And so that's the electron configuration. For an oxygen atom. Not an oxygen ion now, but an oxygen atom. So now let's go to the oxygen ion. Okay? So for the orbital notation, now you don't have to color code it. I'm going to kind of color code it to show you where the new electrons are going in there. You just simply, first thing you do is to write out the original orbital notation. One in each box. Then come back and pair them up. And so what we're going to look at is what's the easiest way to fill up a highest energy level. Okay? The easiest way to get a completely full highest energy level for oxygen is to put 2 more electrons in there. And so I'm adding 2 extra electrons. But if I add extra electrons, this oxygen that I've just created here has 8 protons, and it had 8 electrons to start with. In the atom we have 2, 4, 6, 7, 8 electrons. So the electrons are negative, the protons are positive. They cancel each other out, 8 and 8. So that atom, the atom is always neutral, has a neutral charge. The ion is called an ion because it's not a neutral charge. It's going to have some kind of charge, either positive or negative, and maybe more than one. So it might not be negative, it might be 2 negative or 3 negative or 7 negative. It's possible. Not likely, but could be. So if I've added 2 extra electrons, that means that this oxygen has a 2 negative charge. It's got 2 more electrons, which are negative, than protons, which are positive. And so we can't just leave this oxygen symbol here. It has to have the 2 negative symbol as a superscript. Otherwise, you're not telling the truth about what this orbital notation is. Okay? You have to have the 2 negative there if you have more protons than electrons, or for that matter, well, I said more protons, more electrons than protons, or if you have more protons than electrons. In either case, you've got an ion, you've got to have the correct charge there to show that. You don't have to color code your electrons, as I did, but you do have to have the charge there. All right, now for the electron configuration for oxygen, then we do the same thing only for this orbital notation. So it's 1s, 2, 2s, 2, and 2p. Now we have how many electrons? 6 of them. So this is 2p6. So for the oxygen ion, O2 negative, the electron configuration is this. Okay? Now, what is the name of this? Anytime you have a single atom that you've added electrons to, so an atom with a negative charge, got it? That's not an atom anymore, it's an ion, but we changed the name of that ion to have an IDE ending. Okay? So the name of this name of the ion is oxide. Okay? You could call it oxygenide, I suppose. Given the rules you had yesterday, would have been acceptable, but we just call it oxide. Kind of sounds better, doesn't it? Oxide. All right. And then the symbol for this ion is that same thing we put at the front of this. It's O2 negative. Does that make sense to everybody? Anybody have questions about that? All right.